Everybody, Mr. Martinez here. Wanted to say hi to everybody, and I miss you, and I hope you're doing well. Uh, Today, what we're going to be discussing is circumference and area of a circle. I know that that's part of the homework that you had last week before school closed, but I wanted to go over it with all of you. So, where these two come from, the circumference and the area of a circle, are really interesting, and we'll go over where they come from. So, last week we practiced creating an equilateral triangle, and then what we did with that equilateral triangle is we used a compass to create a circle around the triangle. And notice how that circle touches the triangle at three different vertices. So notice how each vertex is is intersecting the circle. Well, we can actually do the same thing with any regular shape. So remember, a regular shape is a polygon that has congruent sides and all the three angles are congruent. So for example, this equilateral triangle is a regular triangle. Here we have a four-sided shape, which is a quadrilateral. More specifically, this quadrilateral has four congruent sides and four congruent angles, which we know is a square. So this square is inside the circle. Well, what about if we continue to create a five-sided shape? Or for example, a six-sided shape, which is a hexagon. And this one is a regular hexagon. Remember, all six sides of the hexagon are the same length, and all six angles of the hexagon are congruent. So notice how the circle is intersecting each vertex or vertice. Well, here we have an octagon. Octagon means 8. So this is a regular octagon. Notice how the vertices are again crossing. Now you might notice that these vertices of each shape, they're increasing. And as they're increasing, these vertices start to get closer to each other. And so here for octagon, you can see that these vertices are a lot closer than the vertices from a triangle. So as we continue to increase the number of sides, notice what happens. So for example, notice these pink or red points. They are all a representation of a vertex of a polygon. And I believe this polygon has 100 sides. So notice what's happening. These vertices are getting closer to one another. Eventually, they're going to get so close that it creates a circle. So I'm going to go ahead and show you a video of what I am talking about. So you can see that these are slowly becoming a circle. Notice how these vertices are getting a lot closer, and now we have a circle. I'll play it again because you might have missed it. So again, notice how these vertices are all getting closer, eventually becoming a circle. So coming back to this statement, as the number of sides in the polygon increases, notice how these sides are increasing. The vertices end up creating a perfectly round circle, just like we saw in the video. Well, a really important part is mathematicians, when they were trying to figure out how can we find the area or circumference of a circle, they realized that it's the same thing as if you found the area of a triangle or the area of a square, the area of a hexagon, the area of an octagon. Eventually, they realized that the minute you got to a shape that had 10 sides, they ended up getting the same number for the area of a polygon that has 11 sides, of a polygon that has 12 sides, of a polygon that has 13, 14 sides, or 100 sides like this one. So the area of an 100-sided polygon ended up becoming the same number or stayed the same as the area of a 10-sided polygon. And so that's how mathematicians came up with the area formula. And I'll show you the area formula. So the area formula is this, which is pi r squared. Now, how they came up with that is, again, when they took the area of a 10-sided polygon, so I'll go back to this. When they took the area of a 10-sided polygon, they got a certain number, which was 3.14 dot, 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 dot. And then when the polygon became a shape that had 100 sides, that area stayed the same. It stayed as 3.14 dot, 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 dot. And so they decided to name 3.14 as pi, and radius, of course, is from the center to the circumference. Well, we can also have here, this is a good, if this was the center, then notice how that is also, that's the radius, but it also happens to touch the vertex. Or again here, this is the center of the circle, and it also happens to go to the circumference and to the vertex of the square. Same thing here, center goes to the circle, and that's the radius. So same thing here, center of the circle, let's say, and then I can go to a vertex or also the radius. So that's where the radius comes into play. The same thing happened, so remember, area is if you were to take a flat piece of paper or just paper, and then if you were to use a color pencil, and if you were to shade in this circle, then that is what the area represents. Area represents everything that is shaded inside the circle. Now, circumference is different. Circumference is the perimeter of the circle. So if I was to go all the way around, what would be the perimeter that I just walked? Or for example, here, what would be the perimeter of the triangle, which is all the way around? Or the perimeter of the square, which is around the shape. Same thing with the circle. Because this polygon ended up becoming a circle, what would be the perimeter of that polygon that's now so smooth that it became a circle? And mathematicians, again, figured out that when we have a polygon that's 10 sides or larger, they kept getting double of 3.14. So they kept getting 3.14 times 2. So I can show you what that is. 3.14 times 2. They kept getting this number, 6.28, over and over again. They got that for a shape that has 10 sides, 11 sides, 12 sides, all the way towards infinity. And then they, again, because they had to use pi as 3.14, they kept it as pi. And so this is what the formula is. We take 2 times pi, and now you know where that came from, or the 2, and then times the radius. So the radius is, again, from the center to the circumference. So hopefully that gives you an idea of where area and circumference come from. Okay, now we're going to do an example. Feel free to pause here if you want to take a break or continue. Okay, so this one is saying determine the area and the circumference of the circle. I'm using my finger on the trackpad, so I'm going to be moving a little bit slower, but feel free to follow along. Remember, area is if you were to fill in the circle with a color pencil. Okay, so if you were to shade it in. And that formula is pi, which is 3.14, but we're going to use pi to be exact, times the radius, squared, and we're only squaring the radius. So the area, feel free to use a calculator or Desmos scientific calculator. So that would be 7 squared, and then it's 49. Okay, so 49, we want to keep it as exact, which means we do not want to approximate pi, so we're going to put 49 pi units. So whether the circle is measured in inches or centimeters or meters, 49 pi units squared. So that is the area. Okay, circumference again is if we go around, or the perimeter, if you were to walk around. So circumference, remember the formula is 2 pi, and again, that's because mathematicians found that it was double of 3.14 for the perimeter times the radius. Now, of course, it makes sense that if the circle is larger, and we measure that by measuring the radius, then that circumference will also get larger with respect to that radius. So circumference will be 2 pi, remember times pi, times 7. And that's going to be an exact answer of 14 pi. Now here, because we have not found area, it's just going to be units. So not squared, just units. And that is what the area and circumference of this circle is. Okay, again, feel free to pause at any point. Feel free to rewind this video if you need more help. I'm gonna go ahead and show you a trickier one. And this is more of a challenging one. So if you get confused, no need to worry. It's more challenging, but I think you can follow along. All right, so find the area of the shaded region. So notice how this is a square. Remember, a square has 4 congruent sides. And notice how we have a circle on the inside. So this one's a little bit tricky. Go ahead and take a moment to think about how you might find the area of the shaded region. Feel free to pause. Okay, we're gonna go ahead and try this one. So here's the game plan. We wanna find the area of the square. So first, I'm gonna find the area of the square. And you might remember from middle school that the area of the square is just 6 times 6, which is going to be 36 inches squared. And it's squared because we're finding the area of the square. So you want to make sure you put the units and you put the square. Okay. So what we want to do now is we want to find the area of the circle. Now, because this is a square and there's a circle inside of it, that means that the center of the square is also the center of the circle. So therefore, if you go from the center of both to here, that's going to be the radius of the circle. Now, it might be a little bit more clear. Let me go from here. From the center of the square and circle, that's the radius. So notice how this square is 6. Half of 6 is 3. So the radius is actually 3 because the diameter, or the side of the square, is 6. Okay, so what we're going to do is we're going to use 3 as the radius. So now we're going to find the area of the circle. And the area of the circle, remember, it is pi r squared. And then you're going to end up getting 9 pi, and we're going to use inches squared. Remember that 9 pi is similar to 9 times 3.14. So we can kind of get an idea of what that means. So now what we're going to do is we are going to subtract these two. We're going to take the area of the square, and then we're going to subtract it by the area of the circle. And that's going to be the following. So area of the square is here. I will highlight it in blue. This is the area of the square. And then the area of the circle is this one in green. So this is actually our answer. Now I know it looks really funky, but that's okay. If we want to kind of get an idea, a numerical idea, we can use decimals. So if we want to know what that is as a decimal, we can do the following. We can do 36 minus 9, use the pi button, and then that will give us 7 point, this decimal. So the area of this shaded region is 7.72 inches squared, which is a lot smaller than what the square is, right? The square is 36. So that gives you an idea of what this one will be. Why don't you take a moment to try to figure this one out, how you would do it. Feel free to pause. Okay, the game plan for this one is we are going to find the area of the big circle. So we're going to find the area of the circle, and that's going to be, remember, pi r squared, and that's going to be 64 pi centimeters squared. And then we're going to find the area of the white circle. So for that one, I will use the green. So for that one, I'm going to do pi r squared. Remember, r is 5, so this is going to be 25 pi. And we want to leave it as exact, meaning we want to keep the pi Greek letter in there. Okay, so now the game plan is we're going to take the area of the whole circle. Okay, we're going to take the area of the blue, and then what we're going to do, we are going to subtract the area of the green. And then when we do that, we're going to be left with the area of the shaded region. So we can actually subtract this number, and the reason why is because we have like terms. So notice how they're both numbers with a pi in it, and because they have like terms, meaning they both have pi, we can actually simplify. So just kind of think of it as 64 minus 25. Again, you can use a calculator, and then this one's going to simplify down to 39 pi. So again, think about what that is. That's 39 times 3.14, but we want to leave it as exact. But if you want to kind of get an idea, 39 pi, so that's going to be 122.52 centimeters squared, which is less than 64 times pi. Okay. That was the lesson for circumference and area of a circle. Feel free to ask any questions this week via Schoology, or if you want to schedule a video chat, we can definitely do that. Have a great day, everybody. Bye.